First called law of dilution, we know that degree of dissociation is directly proportional to degree of dissociation is directly proportional to dilution or inversely proportional to concentration. If we have more concentrated solution, that means dissociation will be less and dilution will be more, then dissociation will be greater. So I have a question on this topic. Which of the following compound having highest percent of dissociation, that means alpha? Option A is 1 molarity NH3. Option B is 0.1 molarity NH3. Option C is 0.01 molarity NH3. Option D is 0.001 molarity NH3. Very good, Ifra. Krishna, any answer? Fawaz?
Sir, option D.
Option. Not option B, it's option D. Why? You can see molarity, that is C. Concentration, alpha is equal to Ka upon C. This is concentration. And if concentration is high, alpha is low. And if alpha is low, dissociation is low. So according to our question, highest percent of dissociation, that means alpha has a very big value in which the constant, if concentration is low, the value will increase. So option D. Okay, is that okay, Krishna?
Yes, sir.
Okay, thank you. Now we are going to see this. Right topic, ionic product of water. Ionic product of water is basically Kw. We represent ionic product of water. Kw, you know that H2O in liquid state will give H plus or OH, H plus plus OH minus. Or we can also write H2O will give, since H plus is highly unstable, so H plus exists in the form of hydronium ion H plus, H3O positive, and this is OH negative, and you can balance it. This is known as hydronium ion. H plus is highly unstable, so it makes bond with water and form hydronium ion, that is H3O positive. Is this clear? There is no difference between H3O positive and H plus. It represents acidic character, that is H plus. Okay? Okay, everyone?
Yes, sir.
Yes, sir.
Okay, sir.
Now see, if I'm going to write Kc for this reaction, either this reaction or this reaction, same it will be. So Kc is equal to H plus into OH minus upon H2 upon H2. Now, can you write it in the same way that I did for HA? Please write it. Now you can see that I can multiply Kc into H2O, that will be equal to H plus OH minus, and this Kc into H2O is basically ionic product of water, Kw. This is also a constant because H2O in liquid form, pure solid or pure liquid, the molar concentration or active mass of, I told you in chemical equilibrium that active mass of pure solid and pure liquid is 1. That means it is constant. So you can see that this is known as basically ionic product of water. Ionic product of water, this Kw. So the Kw will be equal to H plus into OH minus. Is this clear, everyone?
Yes.
Okay, just
Yes,
write
sir.
it. Very good. Just write it and let me know if you are done with this. Or we can also write at the place of H plus, we can write H3O positive, and this will be OH minus.
Done, sir.
Fawaz?
Done, sir.
Okay. Now, please write a note. The value of Kw, that means the value of ionic product of water at 25 degrees centigrade is constant. At 25 degrees centigrade is constant, and which is equal to, this value is experimentally done, which is equal to 10 raised to the power minus 14. Now, if the temperature changes, the value also changes. So if we increase temperature, when temperature increases, the value of Kw also increases. The value of Kw also increases due to increase in number of H plus or OH minus. If we increase the temperature, the number of moles of molarity, the concentration of H plus increases, OH minus increases as well. So Kw also increases. So I can write Kw will be equal to H plus into OH minus. That will be equal to 10 raised to the power minus 14.
Sir.
Done, everyone?
Done, sir.
Fawaz?
Yes, sir.
Okay. Now write another note. if Ka upon C, basically this comes from alpha is equal to under root Ka by C. So if Ka upon C, this note is basically regarding where we can neglect alpha and where we can not neglect alpha. It is regarding that. Okay, if Ka upon C less than equal to 25 into 10 raised to the power minus 4, alpha will be equal to less than equal to 5%. And here Ka is equal to C alpha square. That means here we just neglected alpha. But if Ka upon C, this ratio is greater than 25 into 10 raised to the power minus 4, alpha is greater than 5%, and here Ka will be equal to C alpha square upon 1 minus alpha. Is this clear, everyone?
Yes, sir.
Yes, sir.
So it's so easy to understand this. Please write it.
Done, sir.
Done.
Done, sir.
Done, sir.
Fawaz.
Done, sir.
Oh, Saif, you are here.
Yes, sir.
Wait a minute. We started from here. Just take a screenshot and let me know if you are able to do the first question, please. Wait for a few minutes, please. Are we done with this slide, sir?
Yes, sir.
So this is basically ionic product of water, like we found Ka and Kb. In the same way, we found Kw. Kc for this dissociation, we calculated at the end Kc into H2O, we just replaced by Kw, which is known as ionic product of water. Are you done with this?
Yes, sir.
And experimentally, we found that the value of Kw at 25 degrees centigrade. This is very important. At 25 degrees centigrade, the value of Kw, or you can say the product between H plus and OH minus, is equal to 10 raised to the power minus 14. But if you increase the temperature, this value will be increased because number of H plus and OH minus will increase. Okay. Are you done with this too?
Yes, sir.
Saif?
Yes. Yes, sir.
Okay, just take. And you are here. Everyone done with this slide?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So a new topic today will come. We will start a new topic. That is basically solubility product, that is KSP. We denote it as KSP, or solubility product constant, we also say it. Solubility product constant, that is KSP. Is this clear, everyone? Done with the heading?
Yes, sir.
Yes, sir.
Now, before this, I'm going to,
सर हेडिंग अभी दिख रहा था.
okay, just do it and let me know. You write a point here. It is, basically, it is applicable. It is applicable for sparingly soluble salt. Do you know what does sparingly means? Anyone?
No, sir.
That means it is not completely dissolved or soluble. That means it is slightly soluble. Is this clear?
Yes, sir.
Yes.
Or you can say, in other way, you can say weak electrolyte, right? The one which dissociate into ants that will be soluble. Here, solubility product or solubility product constant is applicable only for a sparingly soluble salt. That means this is not completely soluble. It is least soluble, or it is slightly soluble in. It is slightly soluble. Is this clear? Generally, the salt of D block element is sparingly soluble. Is this clear?
Yes, sir.
Yes, sir.
Very good. As for example, just suppose AB is a salt. Salt, that means it comes from a neutralization reaction. The reaction between acid and base gives salt, right?
Yes, sir.
Yes, sir.
Now, AB here is in solid state, but when you will take it in aqueous solution, it will dissociate into two ions. That will be A plus, and the another will be B minus. Is this clear?
Yes, sir.
Now, you can say this is basically undissolved solute, and this is basically dissolved solute. Write with me, dissolved solute. Okay, Fawaz?
Okay, sir.
Okay. Let me know when you are done. Saif, is there any doubt?
No, sir.
Okay. So how many chapters do you have left?
So I think 3 more.
3 more. In which S block, I think, P block, and hydrocarbon, right?
Yes, sir.
Yes, sir.
Okay. After this chapter, we will go for hydrocarbon first. Okay?
Okay, sir.
Oh, okay. Then S block, then P block. Okay. If you are
Done.
done with this, let me know.
Done, sir.
Done, sir.
Fawaz.
Yes, sir. Done.
Okay. So here comes solubility. Now going to introduce how many types of solubility are here. First, write a topic, types of solubility. Types of solubility. On the basis of, this is very important, on which base we are dividing? On the basis of types of, wait a minute, types of solution. This is basically types of solution on the basis of solubility, on the basis of solubility. So we are going to study types of solution on which base? On solubility. Okay. So here comes first. There are 3 types of solution on the basis of solubility. The first is basically saturated solution. saturated solution. First, let me write it, then I will explain it. Basically, what is this? Write with me. The solution in which maximum amount of solute dissolved or further solute cannot be dissolved is called saturated solution. Is called saturated solution. Just focus on it. Just say you just take a glass of water and start mixing sugar in that glass. A time will come where no sugar can be added, or you can be more specific, no sugar can be dissolved anymore. No sugar can be dissolved. At that point is called basically saturated point, at which no sugar can be dissolved, and that solution is known as saturated solution. No sugar can be dissolved, that means it will be in its solid form. Is this clear? Krishna, Ifra, Fawaz,
Yes, sir.
Saif?
Yes, sir.
Yes,
So
sir.
in this, yes, Fawaz.
Ah,
Okay.
yes, yes, sir.
Okay. So in this, basically solubility equals to molarity. Molarity of solution is equal to solubility. Just write it. If you have given that the molarity of solution is this and the solubility is this, they are equal. That means saturated solution. If greater than and less than, then we will see what happens.
Done, sir.
Done, everyone?
Yes,
Yes, sir.
sir.
Okay. Now, second solution, that is unsaturated solution. What is unsaturated solution? The solution, write with me, the solution in which further amount of solute can be dissolved is called. That means after maximum further amount of solute can be dissolved is called unsaturated solution. Is called unsaturated solution. Is this clear? In this case, amount of solute less than solubility, or you can say solubility is greater than amount of solute, so that we can add some more solute to the solution. And the C is basically super saturated solution. Is there any doubt in unsaturated solution? Krishna, Saif,
No, sir.
Ifra,
No, sir.
Fawaz?
सर फिर से एक्सप्लेन करेंगे?
Yes, why not? the solution in which more solute can be added, more and more solute can be added, that solution is called unsaturated solution. So I wrote here that solubility is greater than amount of solute. Is this clear?
Okay.
More and more
Yes.
solute can be added, that is unsaturated solution. Okay.
Okay, sir. Thank you.
Done, sir.
Done, everyone?
Done, sir.
Wait
Yes,
a
sir.
just right. Super saturated solution. Write its definition. The solution in which extra amount of solute is precipitated. Precipitate, you know, everyone knows about PPT, precipitate.
Yes, sir.
When solution comes to rest, or when solution comes at rest. So in this solution, what happens? Basically, when you add solute and then steer it, it will move, it will be in motion. But when it comes to rest, some of the solute is precipitate out, or some of the solute is in solid state. That means it is not dissolved. So we can write amount of solute greater than solubility. Just write it. Is everyone done with this?
Yes.
Yes, sir.
And write a point which is very important. Just light just went off, that's why I just turned off my video. Okay,
Okay, okay.
Okay, sir.
will it be okay?
Yes, sir. No problem.
Okay, thank you. It is less stable, right? It is less stable solution. Let me know if you are done with this. Okay.
Done, sir.
Done, sir.
Okay. Just see here, AB is a basically salt which is aspiringly soluble, and if it comes in aqueous solution, you just put in water, it will be converted into A plus aqueous plus B minus aqueous. Okay. Now, if you are going to write Kc for this reaction, it will be A plus B minus upon AB. Everyone okay with this?
Yes, sir.
Expression for Kc. Now can I also write like Kc into AB will be equal to A plus into B minus? Can I write this? Saf, you are not speaking up.
Yes, sir.
Yes, sir.
Now, this basically this Kc is constant and AB is in solid state. That's why it's also constant. And constant into constant is equal to constant, and this constant is known as KSP, solubility product, or you can say solubility product constant. So KSP is equal to A plus into B minus. Is this clear, everyone?
Yes,
Yes.
sir.
Just write it. Since now we got the expression for KSP, now we can easily define KSP.
Done, sir.
Done, sir.
Saf and Krishna.
Just a minute, sir. Done, sir.
Okay. Now going to define it. Solubility product. Solubility product. It is defined as, write with me, it is defined as product of concentration of ions raised to the wait a minute. Everyone wrote this?
Yes, sir.
Yes, sir.
Okay, write it. Product of concentration of ions raised to the power of their stoichiometric coefficient. Stoichiometric coefficient in saturated solution at a given temperature. After doing this, let me know, please.
Done, sir.
Done,
Done, sir.
everyone? Now see, if I'm going to give you AXBY, this is in solid state. After mixing in water, it will be XA raised to the power. This is basically cation, and this will be basically anion. Can I write it or not? Let me know if
Yes,
you
sir.
have any doubt in this. Saf, Fawaz, Ifra, Krishna,
Yes, sir.
Yes, sir.
Yes, sir.
can I write this?
Yes, sir.
Okay. Basically, how we write it is very important. If we have a Al2SO4 whole thrice, please dissociate into ions. And let me know the product side. Any answer? Very good, Krishna. So what happens here? How many number of aluminum atom? 2 aluminum atom. And whatever in here, just put it in positive. Then how many number of SO4? 3. SO4. And whatever here is the number cross multiplied, it will be in negative. In the same way, I wrote this. Is this clear, Efra?
Yes, sir.
Yes, sir.
Everyone, now come to this. Ax by. Can I write KSP is equal to A to the power x into B to the power y? Can I write it or not? If you have any doubt regarding this, please ask me. Anyone? Is this clear, everyone?
Yes, sir.
Sir, can you explain?
Okay. Just write the value of Kc like we did for AB. Kc will be equal to A is this, and whatever is the stoichiometric coefficient that will be in power, right? Krishna, according to Kc, expression of Kc,
Yes, sir.
this is the coefficient, so it will be in power and it will be Ax by. Wait a minute. Ax by. So what happens here is Ax by, and I can also write Kc into Ax by will be equal to A y plus power and x. In the same way, this. And you know that this Kc into this solid multiplied, the product of this will be equal to Ksp. Right, Krishna?
Yes, sir.
So you just don't need to write all this step. You just need to dissociate into ions and write only the product side and just write it Ksp. That's why I define it. It is defined as product of concentration of ions. Product of concentration of ions raised to the power of their stoichiometric coefficient in saturated solution at a given temperature. This product that means multiplying between concentration of ions to the to raise to the power of their stoichiometric coefficient. Okay.
Yes, sir.
Just write it and let me know if you are done with this. And write a note. KSP gives an idea of solubility. KSP gives an idea of solubility of salt in a given solution.
Done, sir.
Done, everyone?
1 minute, sir.
Yes, sir.
None.
Done, sir.
Okay. Now, write the topic. Relation between solubility and wait a minute. Yes, solubility and solubility product. Always remember that solubility is expressed in terms of molarity. Solubility is expressed in terms of molarity, like we did for Kc. Kc is in terms of molarity, right?
Yes, sir.
So we have to find a relation between solubility that will be represented by S and solubility product that is represented by Ksp, right? Everyone?
Yes, sir.
Now, everyone done with the topic?
Yes, sir.
Yes.
Now we have a salt AB. In aqueous solution, it will be converted into A plus aqueous and B minus aqueous. You know that 1 mole of this will give 1 mole of A plus and 1 mole of B plus, right? B minus.
Yes, sir.
So just suppose the solubility of this is S. So the solubility of this will also be equal to S, right?
Yes.
Is this clear? Because here the molar stoichiometric 1 mole will give 1 mole and 1 mole.
Yes, sir.
So if you are taking solubility of A plus is S, then B minus will also be S. Okay. Now write the expression for Ksp for this reaction. Ksp will be equal to A plus into B minus. Is this clear, everyone? Ifra?
Yes.
Yes, sir.
Now, if we know that this is what this in Kc, it was basically molarity. In Ksp, it is also molarity, but this molarity represents solubility. How many moles per liter is soluble in the solution? So we just took it as S into S will be equal to Ksp. So S square will be Ksp. And here we can also write S will be equal to Ksp. You will see different reactions will have different relation between Ksp and S. S represents solubility. S represents solubility that in terms of mole per liter. And this you know that it is solubility product constant. Ksp is solubility product constant. Solubility product you can say, or solubility product constant you can also say. So it is the first reaction. For different reaction you will see it will have different relation. Very good, Ifra.
Done, sir.
Very good. Everyone done?
Done, sir.
No, sir. Wait.
Okay, waiting.
Yes, sir. Done.
Okay. Now another reaction I am going to take is A to B. Now split or dissociate it into ions on your own. Can you? and find a relation between KSP and no. Just see here, A to B. So it will be 2A positive. Okay. Very good, Krishna. Very good. 2A positive plus B minus 2. Why does it minus 2 comes? Basically, can you see any charge in A to B?
No,
Ifra,
sir.
Fawaz.
No.
No, sir.
So basically, this is neutral compound. Neutral. If we dissociate into ions, you can see here is 1, so the charge will be plus 1, and 2, A is 2 in number, so 2A plus. Now total charge on this is plus 2, right, Saif?
Yes, sir.
So it must have 2 charge minus 2 overall. It is only 1, that's why I just wrote minus 2. If it will be 2 or 3, that we calculate and write its value. So the value will be B minus 2. So that minus 2 plus 2 will be neutralized. Okay, Ifra?
Yes, sir.
Now come to the point. If I'm going to write the term KSP, before KSP, you are going to write the solubility. Solubility is S. Now here, since 2 is the coefficient, here the solubility will be 2S, and here only one coefficient, so the solubility will be S. Is this clear? Krishna?
Yes,
sir.
Yes,
sir.
sir.
Now, if we are going to write KSP, is there any problem to anyone? Fawaz, Saif?
No problem.
Okay, going to write the expression for KSP, it will be A plus to the power 2 and B minus 2. Now, what is the value of A plus? That is 2S. So 2S whole square. And here, what is the value of B minus 2? That is S will be equal to KSP. So KSP will be equal to 2 to the 4. 4S square into S, that will be equal to 4S cube. So different equations or reactions will have different value.
हेलो सर।
Yes, done.
नहीं ये a प्लस स्क्वायर क्यों है? ये b माइनस 2 भी स्क्वायर होना चाहिए।
No, if you are going to write Kc for this reaction, it will be A plus whatever is the coefficient, it will be in power. This is
Okay, okay.
not the power, this represents cation and anion. Okay, Fawaz?
Okay, okay, sir.
Okay. What is 3D? It will be in negative now. Efra? So this will be like A plus 3. And here it will be 3B negative. You want to say that this, Ifra?
Yes, sir.
Okay. Write a relation between KSP and S.
सर a माइनस 3 है ना?
Not minus 3. First position represents cation. NaCl. What does this mean? According to IUPAC, first position in inorganic compound is cation. Okay, so it will be always, we take it as a reference positive. Okay.
Okay, sir.
Okay. Very good. Very good, Krishna. Ifra, your answer, Saif. Saif, speak up. Do you have any doubt? Ifra, you made a mistake. Just check it out. I'm going to tell you. Okay, first you have to write the solubility. Since it has coefficient 1, it will be S. Since it has coefficient 3, so it will be 3 thrice. So KSP will be equal to, this is the cation, this is the anion and has coefficient 3, so it will be in power. Again, A plus 3 has a solubility S and B has solubility 3S raised to the power 3. So 3S has cube, that means 3 3s are 9 3s are 27. 27 S cube into S, that will be equal to S raised to the power 4. Not 3S cube. Fawaz, you got the answer? Saif, are
Yes,
you
sir.
there, Saif?
Yes, sir.
Is there any doubt in this? Ifra,
No, sir.
have you
Yes, sir, got it.
checked your answer again?
Yes, sir. I didn't
Okay, can I
give
change the
time.
slide? Oh, very good. Can I change the slide?
Yes, sir.
Sir, 1 minute.
Okay, okay.
Sir, is this the last topic for the chapter?
One more topic that is basically common iron. It's a small topic that is related to basically Lee-Chatterjee's principle. Most probably in the next class, we will
Done,
have
sir.
a new chapter after half an hour of the class. Okay, Krishna.
Okay, sir.
Okay.
Done, sir.
Everyone done with this? Can I change the slide, Saif? Saif, are you? mm, Saif, are you getting it all, or do you have any doubt regarding this topic? Saif, are you there? Okay, everyone. So now do this A to B 3 times. Very good, Krishna. Any other answer? S raised to the power 5.
Yes, sir.
Very good. Ifra? So you can see here that it will be 2A plus 3. This is cation. And here it will be 3B minus 2. Very good. So for KSP, I am going to write it directly. I'm going to write it directly. So it will be basically 2s raised to the power 2 into 3s raised to the power 3. So it will be 2 to the 4, 3 3 is 9, 3 is 27 into 4, that will be 108. S square into s cube, that will be equal to s raised to the power 5, and this will be your answer. Okay. Ifra?
Yes, sir. Sir.
Okay. Now do the same thing with this ax by. From this we are going to generalize and make it a formula. You can see it will be like a x a raised to the power minus y. That means this is cation, and you can see this will be our anion. Right, everyone? Now, in the same way, if you are going to see the solubility, this has a solubility XS, and this will have a solubility YS. In the same way, KSP will be equal to, you know that it will be A Y plus raised to the power X, B X minus raised to the power Y. Now you will see the value of A Y raised to the Y plus have a value XS, have a power X, and it will be YS have a power Y. KSP. Now we can also simplify it. KSP will be equal to X raised to the power X, S raised to the power X, Y raised to the power Y, S raised to the power Y. So KSP will have a formula you can easily apply if you will have remembered it. X raised to the power X and Y raised to the power Y and S raised to the power X plus Y. S raised to the power X plus Y. Please write it and let me know if you are done with this.
Done, sir.
Done,
Done, sir.
done everyone?
Yes, sir.
Awaz and
No, wait,
Steph.
sir.
Steph, what you just said?
Wait a minute, sir, please.
Okay, okay.
Done, sir.
Okay, everyone done with this? Very good. Now we are going to apply this KSP in different questions, in terms of question. So you can see the solubility product of AgCl, starting from a very easy question, is 10 raised to the power minus 10. Calculate the solubility of AgCl. Calculate the solubility of AgCl. Can you do this or should I explain it?
Yes, sir.
Krishna?
Sir, can
Sir?
you explain once?
Okay. So here in the question, it's given that solubility product has a value that will be equal to 10 raised to the power minus 10, right, Krishna?
Yes, sir.
Now, solubility of AgCl, we need to calculate. That means we need to calculate AgCl. So I'm going to write a equation AgCl that will be equal to Ag plus, very good, Ag plus Cl minus, right? So according to the equation, the solubility will be S because it has coefficient 1, and in the same way it will be S. KSP will be equal to S into S. Can I write it directly, Krishna?
Yes, sir.
KSP has a value 10 raised to the power minus 10, that will be equal to S square, and S is equal to under root of 10 raised to the power minus 10, which will be equal to 10 raised to the power minus 5, which will be equal to 10 raised to the power minus 5. Can anyone tell me the unit of this? Krishna, Ifra, Fawaz, and Saif.
What you asked?
I asked that what is the unit of this value? That means what is the unit of solubility? Because we found that solubility is equal to 10 raised to the power minus 5. What is its unit? Meter, liter, kilogram, what is it?
So mole per liter.
Mole per liter. Any other answer? Anyone else?
Mole per liter, sir.
Mole per liter. It will be mole per liter. Because in solubility, I wrote that molarity will be its equal in saturated solution. In saturated solution, after definition, if you will see again, you will find that solubility is equal to molarity. Here, the solubility is expressed in terms of molarity. Is this clear, everyone?
Yes, sir.
Yes, sir.
Very good. Can I change the slide?
Just a second.
Okay, Fawaz, don't you need
Yes, sir.
your 1 second?
नहीं चाहिए.
Okay,
Done, sir.
done. Can I change the slide, Saf? Are you done with this?
Yes, sir.
No. The solubility of MgSO4 is 10 raised to the power minus 4 m. M that represents molarity. Calculate KSP. Done, everyone? Ten raised to the power minus 8 mole per liter. Okay, you can see that. SAF, very good. MgSO4, it will be Mg plus 2, and here it will be SO4 minus 2. Those solubility will be S and S. So Ksp will be equal to S square. Directly I'm writing, and here it will be 10 raised to the power. Wait a minute. We need to calculate Ksp because S is given. So 10 raised to the power minus 4 to the power 2, that will be equal to 10 raised to the power minus 8 m, or 10 raised to the power minus 8 mole per liter. Very good. Fawaz, no answer from you?
Sir, I was doing.
You got?
हाँ मिलने ही वाला था.
Okay, okay. Can I change the slide? Fawaz,
Yes sir, yes, done.
okay. The Ksp of Ag2CrO4, this is known as silver chromate. The compound has a name, silver chromate, is 256 into 10 raised to the power minus 12. Calculate the solubility. Should I explain it or you can do it? It will be done in the same way that you did
We can do it.
last. Krishna, what you just said?
Sir, we'll do it, sir.
Okay, very good, very good. I like the spirit. Any answer? Any answer? Very good. Very good, Ifra. So now you will see that AG2. Any answer? Krishna, Saif, Fawaz. It will be converted into 2Ag and here it will be in positive. Now see total positive charges plus 2. So it will be CrO4 minus 2. Now we know that it will have solubility 2s and it will have solubility S. Okay. So Ksp will be equal to 2s raised to the power 2 into S. And what is the value of Ksp here is 256 into 10 raised to the power minus 12. And here you can see 2 to the 4 S cube. And you can easily find the value of S cube. S cube will be equal to 256 into 10 raised to the power minus 12 upon 4. And it will be cancelled by 64. So S cube will be equal to 64 into 10 raised to the power minus 12. And you can also write S will be equal to 64 raised to the power 1 by 3 into 10 raised to the power minus 12 raised to the power 1 by 3. This is all maths, exponent and maths. So it will be cancelled by 4 times, right? It will be cancelled by 4 times or not?
Yes, sir.
Yes, sir.
Now see, if you can write 64 as 4 raised to the power 3 and here we have a power already 1 by 3 and here it will be 10 raised to the power minus 4. So you can also cancel this. So the value of solubility S will be equal to 4 into 10 raised to the power minus 4 m. Is this clear, everyone?
Yes, sir.
Yes, sir.
Saif,
Yes, sir.
if you are done with this, let me know.
Done, sir.
Done, everyone?
Yes, sir. Done.
Very good. Fawaz, Fawaz, Fawaz is not here. Okay, he just got disconnected. Now see, we got a question. The case P for AlOH whole thrice is 2.7 into 10 raised to the power minus 11. It's a very good question. Calculate the solubility of OH minus. Here, A option is 10 raised to the power minus 3. B option is 3 into 10 raised to the power minus 3. C option is 3 into 10 raised to the power minus 4. D option is none of this. Please do this question carefully. Option C. Now see here. What I'm going to do is ALOH whole threads. So it will be a split like, or sorry, dissociate into Al plus 3. And here it will be 3OH minus, right? Now, this has a solubility S and this will have a solubility 3S. So, KSP will be equal to S into 3S raised to the power 3. And KSP has a value 2.7 into 10 raised to the power minus 11. That will be equal to 27 S raised to the power 4. Right, Krishna? Ifra?
Yes, sir.
Yes, sir.
Now see, if I'm removing this decimal, it will be 10 here, and after taking this 10 raised to the power 1 in numerator, can I write it as 27 into 10 raised to the power minus 12 is equal to 27 s raised to the power 4? Can I write it or not?
Yes, sir.
Yes, sir.
Now you can see this 27 and this 27 will be cancelled, and s raised to the power 4 will be 10 raised to the power minus 12, and s will be equal to 10 raised to the power minus 12 raised to the power 1 by 4, and this will be cancelled 3 times. So the solubility came out to be 10 raised to the power minus 3. But in questions, it is asked that solubility of OH minus. Solubility of OH minus. What is the solubility of OH minus? 3S. You can see from the
Yes, sir.
equation that the solubility of OH minus is 3S. That's why we have to multiply it by this, so that we will get our right answer. Is this clear?
Yes, sir.
Yes, sir.
Very good. Saif, Fawaz,
Yes, sir.
very good. Let me know if you're done with this. Okay.
Done, sir.
Very good, Ifra.
Done, sir.
Everyone done with this? Saif, Fawaz.
Sir, done.
Saif, waiting for your reply. Saif, are you done? Now see the question how it connected pH insolubility. Let me know if you are done with this. Can you do this, Saif? Krishna?
So, can you help
Yes, why not?
solving?
Okay. Concentrate here, please. First of all, here it is given that calcium hydroxide, right? So it will be Ca plus 2 plus 2OH minus. Is this clear?
Yes, sir.
Now, if you will see, the solubility here will be S and here it will be 2S, right?
Yes, sir.
So
Yes.
KSP will be equal to, you can see, if you want to write Ca plus 2, and it will be OH raised to the power 2, and here it will be S into 2S. Wait, it's just lagging. That's okay. See here, it will be like this, right, Krishna?
Yes, sir.
Now KSP will be equal to 4S raised to the power 3, and KSP has a value 32 into 10 raised to the power minus 9 is equal to 4S cube. Okay.
Yes.
You also know that 4 is 8 is a 32, so it will be equal to S cube will be equal to 8 into 10 raised to the power minus 9, and S will be equal to 8 raised to the power 1 by 3 into 10 raised to the power minus 9 to the power 1 by 3. So it will be cancelled by 3 times, and here it will be 10 raised to the power minus 3, and here you can write 2 raised to the power 3 raised to the power 1 by 3. So it will be cancelled, and the solubility of yours will be 2 into 10 raised to the power minus 3, right?
Yes.
Now you need to calculate pH. You need to calculate pH. So you have to calculate first the concentration of OH minus. Concentration of OH minus. So concentration of OH minus is 2S. Concentration of OH minus is 2S. So it will be 2 into 10 raised to the power minus 3. 2 into 10 raised to the power minus 3. That will be equal to this. Krishna.
Yes, sir.
So can you find now the value of POH minus
Yes.
log OH? Can you do this now?
Yes, sir.
Now do it and let me know. Very good, Saf. Very good. Anyone? Any other answer? That is POH. POH is, what is the value of POH, Saf? You need to calculate the value of pH. Oh, wait a minute. POH will be equal to, let me see the option. Calculate the pH. So you need to, it's not 2.47. pH will be equal to, what is the value of POH? 14 minus 2.4 will be equal to 11.6. So the option is C, correct, because according to the question it was asking pH, not POH. Okay, everyone.
Yes, sir.
Okay, can I change the slide? Ifra.
Just a minute.
Yes, sir.
Okay.
Done, sir.
Saif, are you done with this? Now we have another question. The solubility of PbCl2 is S mole per liter. It is 80% dissociated. It is as 80% dissociated. Find KSP for PbCl2. I'm going to give you an option. A is KSP upon 2 raised to the power 1 by 2. B is KSP upon 4 raised to the power 1 by 2. C is KSP upon 3 raised to the power 1 by 3. D is KSP upon 2 raised to the power 1 by 3. Can you do this? For
So can you help solve?
very good. You should try first. Just here, Krishna. PbCl2 will be dissociate into Pb plus 2 plus 2Cl minus, right?
Yes, sir.
Krishna. Now you see that it is 80% dissociated. So 80% dissociated will be converted into product. right?
Yes, sir.
So here the solubility will be 0.8 s, and here the solubility will be 2 into 0.8 s.
Sir,
Is
can
this
you
clear?
repeat again? I didn't get.
Just see, 100% dissociated, 100% dissociated. That means alpha has a value 1.
Yes, sir.
80% dissociated. That means alpha has a value 0.8.
Yes.
And the solubility we take as S. So if you are going for, just see here, initially, just see, initially this is S. After dissociation, 80% of this will be 0.8 S.
Yes, sir.
80% of this, what it will be? 80%, that means S into 80 by 100. So it will be 0.8 S. Will it be or not, Saif? Ifra, Krishna,
Yes, sir.
Yes, sir.
are you getting it, or I need to explain it again? Let me
Got
know,
it.
please. Got it?
Yes, sir.
Okay. So it will be 0.8 S, and here since 2, coefficient is 2, so it will be 2 into 0.8 S. Okay. Okay, everyone.
Yes, sir.
Now see, KSP will be equal to KSP. Wait a minute, it's lagging. KSP will be equal to PB plus 2 into CL minus raised to the power 2, right?
Yes.
PB plus 2 has a value 0.8 S into, here you can see 2 into 0.8, that will be equal to 1.6 S raised to the power 2. Now you can easily solve this. KSP will be equal to 1.6 into 1.6, that will be equal to 1.44.
Yes.
1.4. I'm going to write S into 1.6 into 1.6 into S square. Can I write it or not?
Yes, sir.
Now just solve it. What you need to do? KSP, you need to calculate S, value of S. So just multiply it. How much you will get? 1.6 into 1.6 into 0.8. That will be equal to 2.048 something. 2.048 into S square into S, that will be equal to S cube. So S cube will be equal to KSP. Why it's lagging? Is my voice lagging?
No, sir.
No, sir.
KSP upon 2.048, and S will be equal to KSP upon 2.048 raised to the power 1 by 3. In terms of KSP, the value of S. Or we can also write KSP upon 2.048 is almost equals to 2. So the right option is D. Okay.
Okay,
Yes, sir.
sir. Yes.
Should I slide it up?
Yes, sir. Little bit.
Okay, just let me know if you are done with this. Okay. So the right answer is basically D. Okay. Let me know if you're done with this.
So can you scroll down?
Wait a minute. Is the screen visible?
Yes,
Yes,
sir.
sir.
Done?
Done, sir.
Yes, sir. Done.
Okay. So we are going to have another question. This is homework basically. Why it is? Am I? Okay, got it. Just write a question. The KSP of CaCl2 is 108 into 10 raised to the power minus 15. This is your homework, okay? The volume of water is required to dissolve 1 gram of calcium chloride at 25 degrees centigrade. Okay, so basically this is your homework. And from here we will continue in the next class. In the next class, this chapter will be over and we will start hydrocarbon.
Done, sir.
Done,
Okay.
sir.
Do you have any doubt? Anyone?
No, sir.
Krishna?
No, sir.
Okay, then see you in the next class.
Thank you, sir.
Okay, Saif? Saif, are you there?